basically what you have in this machine, I'll shut it off, is you've got a PC literally shoved into that corner. It's an open architecture off-the-shelf PC, okay? Intel motherboards, Intel processors, all the normal stuff. And it's basically connected to that touchscreen. So the touchscreen is the customer interface. What happens when you shut that this power source off is the PC is shutting down just like you would with UPS services, okay? It doesn't have a UPS in it. So if the power dies, it shuts the computer off. But what we're doing is we're normally logging the computer on and off by turning the power switch on.
Does that battery backup at all?
It doesn't have battery backup. People sometimes will do that with these machines. It gets expensive because the draw on the machines, you know what I mean? So probably to put a good battery backup on this machine would cost you several thousand. So it usually doesn't make sense. Now what does come with the machine is, we don't even have it on here, is a voltage regulator. We'll have to get it. New show.
Sensitive to voltage?
Yes, it is. It wants 220, in which you normally find line voltage is around 208. So it's a step-up transformer and it's a regulator as well. But it comes with the machine. We just include it with every machine because otherwise it just
Step up or step down, whatever?
Whatever. Auto switch. So auto does it for us, right? So on this side it's really simple. I mean, it basically looks like a big copier. Okay? So you've got your CMYK process units. And really what's happening from a technical side is when you're servicing this machine, 1, 2, 3 screws, and this whole process unit slides in. Okay, so it's literally on a rail system, and the technician works on it right here. Okay.
Okay.
So in each one of these drawers, you've got a developer assembly. Okay, so that's applying toner to the drum. You've got the drum itself, which has photoconductive properties. You've got a charging unit, which is applying charge to the actual drum itself. There's a cleaning blade that cleans any residual toner on it, and there's an LED print head. So we're using LED print heads to write the image. Okay. Mm-hmm. Same as the laser idea, but obviously just because of the width, you've got to go to LED versus laser. Okay. The same process is repeated 4 times. All of these parts are the same, so they're all interchangeable. Okay. Obviously, you just don't want to put the K toner in the magenta position. You get what I'm saying, right? So. And then here you've got the fusing unit, so you're using heat and pressure. And depending on the media type, so we're choosing substrate types from here, that's changing electrostatics. It's also changing your temperatures as well. Typically, you're operating around 130 to 150 degrees centigrade is about what you're operating. So the cartridges come like this. And people always ask me the next question is, how much do you get out of that? And of course, everything's relative to how you drive the car, right? So, my car doesn't get very good gas mileage because I believe there's only 2 pedal positions on the way. 30,000 square feet on average. But again, it's very coverage.
Yeah.
So basically what's happening here is it's actually a very simple system. We're using the bottle as the auger, as opposed to putting an auger in. And we spin the bottle on the backside, and that's what siphons toner to the spent with. And this is like a jar, okay? So what the user does is they just break the seal on the jar, okay? And then you insert it in the machine, you close it, and then from there the machine takes over and just loosens the bottle, augers the toner through the screw, through the spout into the machine. So very simple. Now what is happening is there's RFID in this lid here, in the label. So as the machine is consuming toner, we're writing to the bottle, okay, we've consumed 1/8, we've consumed 1/2, we've consumed 3/4. When we get to the end of the bottle, we kill the RFID chip. You know why?
So they don't refill it.
So we can't, so the bottles can't be powered.
Right.
Yeah. The other thing too is then we're able to provide the user with accurate consumable numbers too. But it's really good.
Yeah, I understand.
Hello.
Don't do that. Of course, you never open it when it's full, right? So, and the idea is when you open it like this, then you close the jar before you pull it out. And then what I do is I take the old bag and I just slide it over and slide it in. So.
Okay.
that serves as your disposable base. The toner composite is, in all of our print processes, it's a true non-magnetic monocomponent toner. There's no developer, there's no metal filing, there's nothing like that in the product. So the toner that you put in the machine on day one and the last day is the same. Because this is just a plastic particle, this cartridge can be put into recycling. So it doesn't need any special recycling program. It can be put right into a recycling bin. It's ready to go. Actually, when I got here, the first thing I did was our admin person in Atlanta got these big recycling bins. I hated them at first, and now I love them because for all the prints we do and all this kind of stuff, she's got big. They're on wheels. We roll them into the showroom. We put everything into recycling, and then they pick up. So I've got big recycling bins being ordered for the showroom. Okay, back to the machine. This is, in my opinion, this is the real magic to the machine. If you look at the previous product, we really use the exact same process units in the 80. I'm sure there's some minor improvements mechanically and stuff, but for the most part, almost identical. But this part was completely eliminated, so the 80, the previous product, was literally 1 ton. This machine's over 1,000 pounds lighter, and most of the mechanics were here. And the challenge we had with the 80 was just registering. If you look, you got a large paper path, you're trying to register within 1 pixel of tolerance over 3+ feet, right? So what we did is we use a transfer belt, and a lot of companies use transfer belt to transfer the image from the photoreceptor to the belt to the paper. We use this as a paper transport mechanism. So we're charging the belt, we're applying a charge, the paper sticks to it, and then we pull it across the CMYK drums. And of course, because it's all transporting at a constant speed, it keeps our registration 100% with no user intervention. So there's no calibration that the user had to do. With the 80, they always had to re-register, recalibrate. The other thing we do is we've got these rollers here. What this does is engages and disengages the process units. Okay. So if we're running in K mode, if a customer sends a job that only has black data in it, then we disengage our CMY process units. And
You
now
have to open the back to do it, you do it from the control stick?
It's all done electronically.
Okay, there you go.
Yeah. So the user doesn't do anything.
All right.
The machine looks at the
Oh,
job,
it
identifies that it's only black data, and then does this.
Gotcha.
So what happens is 2 things happen. 1, we know that we can print on 11 Ds a minute. And then 2, disengage CMY process units. Now we're only spinning the K unit. Operating cost goes down considerably, right? Because you don't have wear on these units. The other thing that's happening here is you've got these sensors. These sensors are monitoring voltage. So if we get high humidity situation, if we get just general wear and tear, we're always trying to offset and compensate to keep image quality stable. Okay, so as the parts wear, let me close these drawers because they're all light sensitive.
You recommend it in a controlled environment?
Yeah, needs to be controlled.
Do you have a set limit station?
Yeah, you really need to be above 30% humidity is ideal.
Temperature is 70 to 72?
Yeah, so a typical office environment, and the big thing is we really don't like operating under 20% humidity, and 30% or above is better.
Okay.
30 to 50 is really, the machine likes that the best.
Okay.
So and it's funny because in some of the show environments and stuff, we get less control. It's sometimes tough for us, right? So, and the other thing too is the machine, likes to be leveled, right? We laser level it on the front, but the 80 was a little more sensitive. One of OSA's the sales strategies was they said if you bump the 80, that it would come out of registration, which is a little excessive, right? This one's, of course, even less tolerant. I mean, we really don't do any registration with this machine, where the 80 had a pretty significant registration regimen you have to do. So. Here you've got communication from the printer to the stacker, and that also supplies the stacker with power. Really, you got 2.5 stacking options. We have this one, which is really the preferred, okay? You've got the folding systems, which you can always add. Again, it's a pretty small percentage of our sales. We do have just a straight mechanical rack. We really don't market it, but it's on a 45-degree slant. It's really for limited space environments. I don't think we've sold too many of them, but we added it. One of the challenges we've seen and heard with this, one of the biggest negatives I've heard is just the height of the stacker. It's fine if you're a 6+ foot guy, but if you're 5
Texas, you're a little short.
yeah, if you're a 5 foot woman, it might be a little more challenging, right? So we have that slant stacker. The problem is that the machine prints so fast that it has a limited capacity, where this one has, you know, pretty high capacity.
So that's a reseating stacker? Or is that?
No, it's fixed.
It does not. Yeah, it's fixed. So it works great, but you know, I don't think it has the latest upgrade on it. One of the problems we had with this stacker was, and it was kind of a design flaw, is you can see the way they design these rollers, that they've got this indent. So it was creating a bit of an indent in the print. So they did an update to these to make them flat, so that you don't get an indent in the print. It just looks, it doesn't really hurt the print, but it doesn't look as nice as it could. So,
And for the longer pieces that you run,
you can extend these.
and if they go to 10 foot?
Then you're basically staying in the back of
Catching
the phone.
them.
Yeah.
Okay. So if you're doing a long roll for any reason, you don't have the roll take up.
There's no roll taken. You know, I know it's something we've talked about and not really explored, but.
That's not that
So here you've got an extension rack, and I actually just shoved it up here this morning. The idea to this is it can be utilized as a paper source. So it's a cut sheet auto feeder that'll do, it'll do up to 36, but if you do 24 or less, it'll auto sheet feed for you, up to about 50 prints.
so fun stuff.
Yeah, so it's right here is the feed rollers. It will auto feed for you. So when we use this, the printer actually prints slower. Funny statement. It doesn't really slow down the print speed. What it does is change the inner copy down. Because of course, when you're feeding a sheet like this, the opportunity for error, bad feeds and stuff increases. So we increase the space between the print. So it's inevitably slows your production speed down. Really, it works best as a sheet, as a roll to sheet machine versus this. This is the some of the market needs it, wants it. So
Maximum thickness.
what we say and what you can do is probably a little different. Supporting right now up to 44 pounds. I know you guys typically use points, and I'm not good at the conversion, but I have an app for that if you need it. So let me turn the machine on. Just so when it's at 220, what you'll see is about about 2 minutes for boot up here. Maybe it's a little shorter, and then warm up time, depending on your room temperature, you're about 3 to 5 minutes on this machine from a cold start. You can see it goes through its normal PC.
So it doesn't go into standby mode at
You
night?
can do that. And what you'll see, every machine, is this one mine?
Nope,
No?
that's mine.
That's yours? Okay, mine's in the stand. What you'll see is, in order for us to get the Energy Star on here, we've got to set it so that, I think it's 15 minutes without any data, it goes to sleep, cold sleep, warm sleep, and then 30 it goes to cold. Now what everybody does is, once the machine is delivered, we can set it so at 7 o'clock at night it goes to sleep, and at 8 in the morning it wakes up. Right? That's what most people do, Monday through Friday, and then Saturday and Sunday they shut it off. And then of course if you're expecting a bad storm, I understand you guys might get some thunderstorms in Texas. You might want to shut it off sometimes, right? So you've got 3 paper sources, or 3 rolls, okay? They all load the exact same way. The drawers are essentially interchangeable. And if you've ever loaded an inkjet, you've got to be fairly coordinated and talented and be able to touch your nose and your toes all at the same time. This one's a little different. So you'll see here, so you got teeth here that actually bite into the core. So it's a pretty simple design, right? And you just line up your roll. You just want to grab on the insides of the roll. I'm a VP of sales, guys, so I don't do this very often. So this is our best loading machine out of all the machines we have. So you insert it here, auto take out, okay. Press and hold. We'll do 1 full revolution of the roll, take any adhesive, because there's usually a jagged edge and tape and all that stuff. There's your trim. They're on a lot of toner. So you can see the interface is really friendly. Roldeck one's open. You know, really simple. One of the things that we've done really with all the products is, show it to you in a second, is it's built-in user guides. So as the customer interfaces with the machine, it prompts them, it runs in a toner, says, hey, here's the toner that's out. Do you know how to change that? No, okay, press this button and we'll show you how to do it. And that's step by step. We know you don't read the user guide. We don't either, right?
Exactly.
So, and then here's here's how you set your substrates. Okay, so once you close a drawer, it says, okay, what type of media do you have? So you can choose different, right, bonds, glosses, films, vellums, all that good stuff. And then within that category, then you've got your subcategories, right, based on weight, because the weight is changing the stack change that we require to get the toner. Choose your size right here, say okay, and that's now being applied, and now that information gets broadcast across the network so that people know what size, weight, and type of media are in the machine, and the quantity of paper. So you'll see the 4 bars, it's all based on speed of rotation. So if you put
And each drawer had that same information.
Exactly.
Their own information.
So right now it shows Roldeck 2 is empty, and then 3 has just 1 bar left. So really simple, the interface here. Here's your toner levels. Okay, so it's showing you quantity of toner, and that's based on that RFID information. So that's not one of those things where if you pull the cartridge out, you can't just swap that cartridge at any time, because that RFID information will get right out of sync. So you wait till that bottle's dead, and then you stick the new one in, and it kills the chip. So once it's dead, that bottle's dead, and it needs to be disposed of. Get your media information here, okay, print information here. The idea to this is the ability to be able to walk up with a thumb drive, stick it in here, and you can browse. So you can actually see the information on the thumb drive. I don't have one right with me, but here's some samples. So let's say I wanted to print this one and this one. So there's the 2 images. Next, you can apply a color filter to it. So I could say, okay, I got a CAD color. Next. I can choose my media type. Next, gives my information, hit print, and now if I go to my print queue, it shows me the job in the queue. Now it's ripping me to print that job. The other thing you have is login information. So with every kit machine, we build in full accounting so that you can track username, job number, description. So you can limit and you can access limiting, or you can apply it to your job so you can track usage. You can force all of them.
So typically the first one is 30 to 40 seconds.
Something like that. And I'm gonna send a real job so you can see it here in a second.
Okay.
These are coming off the internal processor, so it's not, you know, maybe a fair representation. Like I said, you're gonna have, so let's say we do a 3 set. We're gonna do 3 sets of, I'll create a job right now, 2 sets. The first set we're gonna have grit time. What you're gonna see is, because it's the large files, and there's a number of them, that you're gonna have some wait time, okay? Because what we're doing is some people use spool. Most printing manufacturers use spool, okay? So you take the job, you take the package, you transfer the entire package in 1s and 0s, it gets to the printer, it rips that entire package, and once the entire package is ripped, which could be 3, 4, 5, 7, 10 minutes, this is, you know, this is how an HP works, receiving data, receiving data, receiving data. Then it starts printing, okay? We don't do that. So what we use is called file transfer. It's the same as what you see when you're doing copy and paste on your computer. We send the header information, which is simply text information saying, here's the job and kind of the basic details of the job, okay? Then we start sending 1 page at a time. The reason we do that is you can rip and print simultaneously. So because we're multi-threading and we've got quad cores, you receive the first page, you process, and you print. As you're receiving the second and third and fourth page, you can be processing into that job while you're printing page 1, page 2, page 3. Now, let's say we rip all of these files. We have number of sets today. The machine prints at full engine speed, but that job's done as far as processing is concerned. If another job's in the queue, we'll now pre-process that job while this job's being completed. And we'll go 2, 3, 4, 5 jobs in, as long as there's enough processing power, so that there's no wait time in these other jobs. So when our machine has lots of jobs in the queue, production's actually higher because we're maximizing, processing time. If you just send one job at a time like that, then it
Does O'Shea
sits.
offer the same?
They do not.
So that's a big plus.
It's a huge plus. But again, production, right? This is a production machine. The other machine's not. Really, you know what I mean? So let me do a job
Isn't that
for you.
similar to the DI? Probably.
This is, so we have 2 hardware configurations. Hardware configuration A, and then B is with a scanner. So the 2300 scanner, which is almost, the de facto scanner we use for this system. And because that product's so tall, you typically have the scanner like this, right, with a scan station. And this one's more of a graphic-oriented scanner, so it uses charge coupled device CCD scanner. Okay. But if you had someone that just had some real basic scanning needs, didn't need this level of scanner, but they did want some copying and scanning capabilities, then we have this scanner as well. You can see it's not fully set up yet, but obviously it's not going to give you the color quality. But if they just need some general input, this works great. And of course the price point's less.
Of the placements you've had, the majority need a scanner? They already have a scanner?
50-50. So 50% of the placements need a scanner, and it's typically more in technical environments.
Do you prefer to sell one of your own scanners if they got one you can marry up?
It's fine. It really doesn't matter. If it's with our scanner, they get a lot more integration and they get more color control. If it's a third party, that's fine. It works.
And that price?
This one, 10,000 retail, closer to 20,000 retail. Fully configured the way you want it, need it.
Okay.
Okay. And what you'll do in a lot of cases is you don't need to add a separate